Welcome to Secrets of Earth. I'm Patrick Viersma, your guide into the world's most remote corners. Today, we descend into the silent deep of the Pacific Northwest in search of a city no human eye had ever seen. Take a breath. Now, imagine you are sinking. The surface vanishes above you. The waves, the wind, the silver skin of the open air. At 30 feet, the warm light of the sun turns gauzy and soft. At 100 feet, the red end of the spectrum disappears, and the world shifts toward a cold, monochromatic blue. At 300 feet, the light is barely a memory. You are entering the deep shelf, a place where the temperature hovers just above freezing, and the pressure is more than a dozen times what you feel on land. This is not the open abyss. This is the continental margin, the great sloping edge of the seafloor, where the world above gives way to the world below. Most people imagine the deep seafloor as a wasteland, a flat, featureless plain of cold mud and silence. And in many places, it is. But if you were to switch on a high-powered floodlight in certain fjords and channels off the coast of British Columbia and descended to around 200 meters, something would stop you cold. Rising from the seafloor before you, in structures taller than a 6-story building, would be something that looks less like a natural formation and more like a Gothic cathedral, carved not from stone, but from glass. These are the Glass Sponge Reefs. They are the only known living reef systems of their kind on Earth. For 40 million years, science believed they were extinct, gone with the ancient seas that once nurtured them. When Canadian researchers first stumbled upon them in 1987, while mapping the seafloor of Hecate Strait, the reaction from the scientific community was, in one paleobiologist's words, like discovering a herd of living dinosaurs. Today, we journey to the floor of the world to meet the architects of one of the oldest living ecosystems on our planet, and to understand what we stand to lose. To understand a glass sponge, you must first let go of everything you think you know about what an animal is. When we think of animals, we think of hearts, lungs, muscles, the machinery of motion and intent. But the glass sponge, specifically the reef-building cloud sponge and its relatives, has found an entirely different strategy for existing in the world. It does not chase. It does not flee. It stands still, opens itself to the deep current, and builds. These creatures are biological glass blowers. They extract dissolved silica, the same element used to make your windows, your wine glasses, the fiber optic cables that carry the internet across continents, directly from the seawater moving through their tissues. Through a process that materials scientists are still working to fully understand and replicate, the sponge assembles this silica into structures called spicules, microscopic needles of glass laced together in precise geometric patterns to form a rigid, lattice-like skeleton. If you were to reach out and touch one, it would not yield the way the sponge in your kitchen does. It would feel like fine porcelain or like the surface of carved bone. And the engineering goes far deeper than the skeleton alone. The body of a glass sponge is shaped, by evolution over hundreds of millions of years, to function as a masterwork of fluid dynamics. Some species take the form of intricate vases, others fan outward like lace caught in a slow wind. Each shape is specifically configured to capture the faint currents of the deep shelf and draw them through the sponge's walls, where microscopic, hair-like structures called flagella beat in coordinated rhythm, sieving out the bacteria, plankton, and organic particles drifting through the dark water. In a place where food is almost unimaginably scarce, these sponges are supremely efficient. The reefs they build collectively filter enormous volumes of water, cleaning it, cycling nutrients through it, and returning it richer than it arrived. They are the kidneys of the deep ocean, performing work that the entire ecosystem depends on, in a place where no sunlight ever reaches. But the most extraordinary feature of the glass sponge is neither its skeleton nor its filtration. It's what's inside. In almost every animal on Earth, cells are discrete individual units. Each one has its own membrane, its own identity, its own boundary. But in a glass sponge, roughly 75% of the soft tissue is fused, merged into a single continuous web of cytoplasm that scientists call a syncytium, from the Greek for together and cell. This creature is, in a very real sense, one giant cell, a single living fabric stretched over a skeleton of glass. And because all of it is cytoplasmically connected, it can do something that no other sponge and very few other animals can do without a nervous system. It can communicate across its entire body instantaneously. When a particle of sediment settles on one edge, when a current shifts, when something foreign touches the sponge's surface, an electrical signal propagates through the syncytium in an instant, triggering a coordinated shutdown of the feeding current across the entire organism. It doesn't have a brain, it doesn't have neurons, but it responds together as one. It is a living circuit board made of glass and seawater, and it has been refining this design for over 500 million years. In the glass sponge garden, time does not move the way it does on the surface. Up here, we measure lives in decades, a career, a marriage, a human span. But down there, in the cold and the dark, these sponges measure time in something closer to geology. Because the water is so frigid and the food so dilute, a glass sponge's metabolism is extraordinarily slow. Some individual sponges, a meter tall, shaped like a chalice, may be over 200 years old, and the reefs they collectively build last far longer still. When a glass sponge dies, its silica skeleton does not dissolve. It remains standing, rigid and intact, often for centuries under the right conditions, providing a hard foundation onto which the next generation of larvae can anchor. Sponge grows upon sponge, skeleton upon skeleton, generation upon generation, the living layered onto the dead, the reef rising in almost imperceptible increments through the dark. The reefs off the coast of British Columbia, in Hecate Strait, in Queen Charlotte Sound, in Howe Sound, have been growing this way for approximately 9,000 years. Core samples from the base of these structures give us that date. 9,000 years of unbroken accumulation. When the first human civilizations were experimenting with agriculture, and the earliest written marks were being pressed into clay in Mesopotamia. These sponges were already centuries into their silent work, weaving glass in the dark at the bottom of a cold Pacific Sea. These reefs have grown to cover roughly 1,000 square kilometers of seafloor. The largest rise nearly 25 meters from the bottom, about 8 stories, in a place where no sunlight has ever touched them, where the only light is the occasional bioluminescent flash of a creature passing in the dark. And what those structures attract is astonishing. In an otherwise flat, featureless landscape of soft sediment, these glass towers are the only architecture for miles. They function as the skyscrapers of the abyss, and, like any city, they draw a crowd. Rockfish tuck themselves into the latticed branches to shelter from predators, using the sponge's geometric complexity like a coral reef provides cover in warmer seas. Golden king crabs and spot prawns navigate the glass-like chambers in a crystal jungle, picking organisms from the sponge's surface. Pacific octopuses settle into the larger cavities, and in the surrounding water column, the sponge gardens support swarms of krill, which in turn attract fish, and fish attract the hunters that follow them into the deep. This is not a barren place. It is one of the most biodiverse habitats in the entire Pacific Northwest, and it is made almost entirely of glass. Among all the residents of the glass sponge garden, there is one relationship so strange, so tender, and so mathematically precise that it is crossed out of biology and into the realm of poetry. In the deep Pacific waters off the Philippines, Japan, and elsewhere in the Western Pacific, there is a glass sponge called the Venus flower basket, Euplectella aspergillum. It grows in the shape of a slender tube, about the size of a wine bottle, its walls woven from silica fibers into a lattice of breathtaking complexity and regularity. Scientists studying its geometry have found that its cross-hatched architecture reduces drag while simultaneously generating small internal vortices, tiny whirlpools that enhance the mixing of water through the sponge's body, making it more efficient as a filter. But the Venus flower basket is famous for something else. When the sponge is young and its pores are large, a pair of tiny shrimp will enter, one male, one female, drawn through the lattice wall as juveniles, small enough to fit through the mesh. They settle inside the sponge's hollow body. They clean it. They feed on the particle the sponge traps for them. The sponge, in turn, provides shelter and food in one of the most food-scarce environments on Earth. But as the shrimp grow, the mesh does not, and eventually they are too large to leave. They will spend the rest of their lives inside this glass house, together. They will mate inside it. Their offspring, hatched small enough to escape through the lattice, will swim out into the open water and find glass sponges of their own. And when the shrimp finally die, the sponge will eventually open its doors to a new pair. It is one of the most complete expressions of mutual dependence in the animal kingdom. The sponge needs the cleaning. The shrimp need the shelter. Neither could survive as well alone. The relationship between the sponge and the shrimp is symbiotic. The shrimp clean the inside of the sponge and, in return, receive food and protection. In Japan, the dried skeleton of the Venus flower basket has been given as a traditional wedding gift for centuries. a symbol in some cultures of a bond that lasts a lifetime. Together until the end. Trapped, yes, but not unhappy. It is a reminder that in the deep ocean, the line between imprisonment and belonging can be made of glass. For 40 million years, these gardens were safe. Their secret was their depth. They existed in a world that human technology couldn't reach, and so we forgot they existed. Or rather, we decided they had ceased to be. The scientific consensus for most of the 20th century was that living glass sponge reefs were gone, relics of the Jurassic, known only as fossil cliffs stretching across parts of Spain, France, Germany, and Romania. Then, in 1987, a team from the Geological Survey of Canada was mapping the seafloor of the Hecate Strait, not looking for sponges, not expecting anything remarkable, when their instruments returned an acoustic anomaly. Something solid and vast was rising from the seafloor, where the maps showed only flat sediment. When the cameras went down, they found the reefs. And then, as researchers began to examine more of the ocean floor in the region, they found more and more. Hundreds of square kilometers of structure that had been building in the dark since before the first pyramid was raised. The problem was that by the time we found them, we had already been fishing over them for decades. Glass sponge reefs are extraordinarily fragile. A sponge that took 200 years to grow 1 meter tall, an inch of growth per decade, is made of the same material as a light bulb. When a bottom trawling net, weighted with metal doors and dragged across the seafloor, passes over a reef, the result is not damage, it is erasure. A single pass can shatter centuries of accumulated structure in seconds, reducing it to a field of silica fragments too sharp and too unstable for new larvae to settle on. It is, in the language of conservation biology, a catastrophic and potentially irreversible loss. Estimates suggest that up to 50% of some reef areas have already been destroyed by commercial fishing before protective closures were established in 2002. Canada has since established marine protected areas around the major reef systems, designating thousands of square kilometers as no-trawl zones. But the recovery timeline for glass sponge reefs, given how slowly they grow, may stretch across centuries. We may have already lost things that will not return within any human lifetime. We are still learning the shape of what we nearly lost. Every time a remotely operated vehicle descends into the deep shelf waters of the Pacific Northwest, it finds something new. A sponge shaped like a trumpet or a chandelier. A species no scientist had cataloged. A relationship no one had imagined. These are not the deep ocean aliens of the Midnight Zone, miles below the surface. They are here, relatively close to shore, in cold water that slopes away from the coast of one of the most densely populated regions on the Pacific Rim. They survived the extinction of dinosaurs. They survived ice ages that covered their home in glaciers. They were building when the first humans crossed from Asia into the Americas. They did not survive us unscathed. We share this planet with millions of stories, most of them unfolding in the silence of the deep or the shadows of the canopy. The Glass Sponge Gardens ask us a simple question. How many things have we been destroying without knowing they existed? Thank you for journeying with me into the world of the glass sponge garden. I'm Patrick Viersba. The world is full of secrets of Earth, if you only know where to listen. I'll see you on the next horizon. Until then, follow our coordinates by subscribing to or following the show. It ensures that you never miss a step into the unknown.